Ultrasound. In this video, I will discuss the basics to the ultrasound medical technique, the transducer, how does it work, the acoustic impedance, and the types of the ultrasound scans available. The basics to an ultrasound technique. Sound hearing ranges between 20 to 20,000 Hz, and this is dependent on the frequency of sound. An ultrasound is greater than 20,000 Hz, and these are similar to sound waves, only that they have a higher frequency. This makes ultrasound as a medical technique that is non-invasive in medical practice. Medical practitioners use a transducer which contains piezoelectric crystals to produce an ultrasound wave. This is dependent on what type of scan. The frequency of the ultrasound will vary. Higher frequencies will give us a better image, while lower frequencies will give us a better penetration. The transducer, and you may have seen a transducer as in the images on the bottom right hand side of this slide. There is a sector, linear or curved transducer, and this is what the medical practitioner will apply gel to do the ultrasound scan. So each transducer contains a piezoelectric crystal which produces and receives the ultrasound waves. The transducer contains crystals such as quartz or barium titanate, which the formation of the molecules in the transducer have no net polarity. The net polarity will change, and this is dependent on the potential difference that is applied. So the transducer will only achieve a net polarity when the potential difference is applied, as I just mentioned. So when a potential difference is applied, the arrangement of molecules will change the shape and in turn produce a sound wave. The frequency of the sound wave is dependent and determined by the frequency of the AC supply or the potential difference. When the transducer receives the signal from the sample area, it will then resonate. How does it work? Ultrasound waves are produced by the transducer as discussed previous in the video. Ultrasound waves penetrate through the body wall with a small portion of the waves being reflected. Then the ultrasound waves hit the first wall of the target organ, and some of the wave energy is reflected while some continues to go through the body. Ultrasound waves reach the other wall of the organ and behave as in step 3. These reflected waves from 3 and 4 steps again penetrate the body wall, which then in turn returned as ultrasound waves and are picked up by the transducer. They are then converted into electrical signals by the embedded piezoelectric crystal, which then conveys an image on the computer. Acoustic impedance of a material refers to the ease with which a sound wave can pass through it. The higher the acoustic impedance, the more difficult it is for the sound wave to pass through, and this can be shown mathematically by the equation Z equals PV. Types of ultrasound scans. There are 3 that I'll discuss in this video. However, phase scans are also an ultrasound scan that I have not discussed in this video. However, the 3 are amplitude scan, brightness scan, and a sector scan. So an amplitude scan is displayed used by wave amplitudes which are plotted against time, while a brightness scan is displayed as fluorescent dots. The more intense the reflection, the brighter the dot, and the sector scan, which is several fluorescent dots as a brightness scan, however combined together to produce a holistic 2D image. And you can see that by the diagrams at the bottom, where an A scan is wave amplitude, while B scan is brightness scan, and a sector scan is shown as fluorescent dots, such as a brightness scan, however as a 2D image. And you can see that there now.